of 2.8 solving linear inequalities. Linear inequalities in one variable, meaning there's only one letter. The A, the B, and the C represent numbers. So we're going to be dealing with inequalities with one letters. And these are examples of equations, and then the counterpart, how they look like when you include inequalities instead of an equation. It's an inequality. That's how they look. And it's only one variable. This is another example, and then again one variable, and then another example, one variable. So think of inequalities when solving them like you would an equation. It's the same thing. There's one variation, and I wrote it here, and I'll show you later how exactly it looks. But when you divide multiply by a negative number, and I mean across to the other side of the inequality, if it's a negative and you're multiplying and or dividing, you're going to flip that inequality. That's the only difference. With the equation, well, that doesn't happen, right? It doesn't have that property. And this is just some words used to, so that's the symbol, mathematical symbol. That's the words that represent that mathematical symbol. This one's, this is just for interval notation. Parentheses is when something's not equal, like this one, like this one right here. So that's not equal. You're gonna use parentheses when using intervals. When something's equal and it has a line like this, you're gonna use brackets. And these are examples of interval notation. So that means it's equal to -1, and it goes all the way to 3, but it's not equal to 3. Infinity, when you use infinity, you're always going to use parentheses. Infinity is you never use brackets for infinity. Okay. So let's do the first example. It says graph when x is greater than 1, greater than or equal to -1. So let's graph that. So x, if you see this graph, imagine any of these numbers can be the x, but we know the x has to be greater than or equal to -1. So look for -1 here. All right, so we know the dot is right there. I'm gonna draw dots. And then I'm gonna say that x is bigger than -1. So that means bigger, you going that way. And if you notice, it has an equal sign, so we're gonna use brackets equal to. So we're gonna use the brackets, and that's how it looks. Now in interval notation, you're gonna write it in this form. So, and if you notice, we already know this is going this way, and it's equal to -1 or greater, so we know it starts from -1, and then it moves to positive infinity. So you draw a comma, and then you're gonna draw the infinity symbol. And remember, infinity you always use a parentheses. So that's the interval notation of this graph and of that. All right, let's move on. So properties of inequality, they have two. So addition property of inequality, and also includes subtraction, meaning you're going to be given an inequality, and if you add something to both sides, the same thing. In this case, they name it C, but you could have added like a number. So you're adding a number to both sides. The inequality symbol stays the same. It doesn't really affect the direction of the inequality when you add or subtract. Now, in the other hand, multiplication property of inequality, that means also dividing, right? So when you're multiplying by a positive number, dividing by a positive number like that, so you're going to be given an inequality, and then you're going to multiply by C. C meaning a number, a positive number. You see the inequality stays the same. It doesn't affect the the position of the inequality. Now, this is very important when c is a negative and you're multiplying. So again, you're given the same thing, but in this case, you're multiplying by a negative number. Then you flip the signs. You see, it was this going this way. Since we multiply by a negative, you flip it to the other side. And that also includes divisions. Multiplication is it's the same thing. So you just flip like that. Okay, example 2. So for the example 2, they're going to give you an inequality and they're going to ask you to solve and graph and then write the interval notation. So for the first thing you need to do is solve. And I have it ready here. So we're going to solve for x. You treat this ones like when you solve equations. So we're going to subtract 4. That becomes 0. You bring down the x. And that one becomes a negative 10. Remember, when you're subtracting or adding stuff, even if it's a negative, the symbol stays the same direction. You don't flip only in multiplication and division. Okay, so now we have the answer for this. So we know that x is less than or equal to negative 10. So look for negative 10 first, and then put a dot right there. So we know we're here. So x has to be less than, so less is this way. Imagine these numbers represent x's, but the x in this case has to be less than 10, so it's got to go that way. That, remember, it has the equal sign, so that means we're going to use the brackets, and it's going this way. So the interval notation, this helps, the graphs helps with the interval notation. So you're going to have a bracket and a negative 10, put a comma, and then it's going to negative infinity. So for negative infinity, you have to indicate it's negative infinity, and then you use the parentheses, remember. And that would be the answer for this one. That's the interval, that's a graph. That's when you solved it. Okay, example 3. So again, they're giving you this inequality to solve a graph and find the interval. So we're going to solve for x. So here we need to get rid of that 2, negative 2. So that becomes 1. So you end up with the x. We divide it by a negative 2, or we multiply by a negative 1/2. But so what does that mean? We're going to change the direction of that inequality. So negative 4 divided by negative 2 equals positive 2. So just remember, we change the direction of this thing. Why? Because we multiply or divide by a negative 2. So now let's graph it. So how do we graph? We find the 2 first, right here. And then we decide which direction the arrow is pointing. X, it has to be greater than or equal to 2. So these round numbers represent the possible x's, but in this case, it has to be greater than these 2. So the only possible answer for that would be on this side, greater meaning that way. Now, are we going to use brackets or parentheses? We're going to use brackets because of that. Equal, greater or equal, so brackets going this way. So we know again, this one helps. You're going to have the 2, comma, and then it goes to positive infinity, and you use parentheses. Okay, the next one, number 4. So they're giving you this, the same thing. Okay, so now, and these are examples kind of related that I think they put them like that by purpose so that you would see the difference. Here we divided by a negative. Here it's the same thing, but the negative is on the other side. We're going to divide by a positive 2. So that becomes a 1. So you're going to keep the x, but we divided by a positive. That negative does not affect that property because we're gonna keep this in the pointing in the same direction, and that would become a negative 2. So they're showing you the difference. When you divide by negative, you flip this one. Even though that was a negative on this case, you divide it by a positive, so it doesn't affect the direction of the inequality. So that's for that one. And then we're going to graph. So find negative 2, put a dot, and then decide where the x's are, the x's for this one. And it says here that x has to be less than negative 2. So these are the possible x's, but they have to be less than negative 2, so they're going this way. Now, we don't have an equal sign here, this is just less, so we're going to use parentheses. So again, for the interval, use this graph, it helps. So parentheses, negative 2, going that way, comma, and then it goes to negative infinity. You have to indicate the negative infinity and use parentheses for infinity always. Okay, number 5. Number 5, the same thing. I forgot to write it down over here. Let me write this one. Alright. So let's solve for this one. This one has some more steps. It's still the same thing. So negative 7. Remember, we need to get rid of this one first. Bring this one down. Again, when you divide or add a negative, it doesn't affect the direction of this. Only multiplication and division. So 9 and 17 both negative, so you get negative 16. And then you divide by negative 4. Okay, here we divided by a negative 4. So we keep the x now, we flip this thing. So remember, we flipped it now because we divided by a negative 4. Let me put it in red so that you guys remember that. So negative 16 divided by 4 would be positive 4. Alright, so now we have it. So now look for the 4, it's right here. And that has to be less than or equal to 4. Okay, so these are the possible x's. Less means that way, those, right? Okay, now what are we using? Brackets or parentheses? We're using brackets because of the equal, less than or equal. So now the interval, we start from 4, comma, negative, right? Negative infinity. Because that way it's the infinity numbers. There's some positives here, but if you continue, you would have negative. That's the answer for that. Okay, for example 6. Okay, so this one has variables on both sides. It's one variable, but it's on both sides. So I'm gonna subtract the negative 7, so that one becomes 0. Bring down the 2x. So negative 7 minus 7 would be negative 18. And then bring the x to the other side. We need to combine the x's, and minus x, minus x. So again, it doesn't affect, we're just adding and subtracting. It doesn't affect the position or the direction of the inequality. Bring down the 18, that became 0, so 2 minus, remember there's a 1 here, so we end up with x, or 1x, but we don't need the 1. And that's, right, the inequality, we solved it for x. So find negative 18, it's right here, and then find which direction is the x going to go. It has to be less than or equal to negative 18, less, these are the x's, less than this would be this way. And then what are we using? Parentheses or brackets? Because of that equal sign, it's the brackets. So again, this helps you for the interval. It's already here, negative 18. And then it goes to negative infinity. And that would be the answer for that one. Okay. So let's move on to 7. Okay, 7 is more of the same, a little bit more complicated. So here we're gonna distribute this one. Let's rewrite it. Let's distribute 2 times x is 2x. 2 times negative 3 gives you negative 6. Okay, now we're gonna move stuff from to the right or to the left. So let me move this to the, I'm gonna move the 6 over to this side. So that's gonna become a 0. You bring down the x. So bring down the negative 5x. 6 plus 7 is 13. Now let's move the x's to this side. Plus, that's negative, so we're gonna use the inverse, which is plus 5x. Comes 0. You keep the 13 on this side, and that's 7x, which they're not done. So this is divided by 7. That becomes a 1. So you have x greater than 13 over 7. Okay, how do you graph a fraction? I would compute this into a decimal. That way you have a clear idea what it is. So 13 divided by 7. So this one would be 1.86. Okay, so these two. That's gonna help you figure out where it is. So x has to be greater than or not equals, just greater than 1.86. So look for 1. 1.86 is close to the 2. It's less than 2, right? It's not yet 2, almost. It's right here. That's so before the 2. All right. So where does the x go now? So it has to be greater than. So I mean that's less than 1.8, and that's greater than 1.8. That's where we want the x to go this way. Now this side, parentheses or brackets, that has no equal sign, so we're going to use parentheses. So for the new way, it helps, right, to see that. So I would write the fraction out. Do not write the decimal. Write the fraction. 13 over 7, right, which is a 1.86. And then, and maybe here you can write 13 over 7. That way you know it's that dot right there. And it's going to positive infinity, so you put positive and then you close it with the parentheses, and that's the answer. Okay. For 8, 8 is more of the same. I'm not gonna do it. I think I'm gonna make you guys do it during the class. Okay, now compound inequalities. So I'm gonna do 2 of them, and then I'm gonna leave that one for you guys. So let's write it here. Compound inequality is just, it looks complicated so for that one, but it's not. It's just, imagine you had 2 equations simultaneously or something like that. So let's graph this one. This is already solved. It's the x is by itself, so we can actually graph this one. So that's not the interval. I wrote it down here, but that's not the interval, not yet. So let's graph it. So you're gonna find 2, put a dot on 2, and then find 4, put a dot on 4. Okay, and it says here that x has to be greater than 2, so it's going that way, right? X greater than this number, but it's also less than or equal to 4. So from 4 is less than, so it's going this way. And for this type of inequality, you wanna shade or where they overlap, and they are overlapping in the middle right here. But before we do that, let's decide which brackets or parentheses are we using for this side. For the 2, we're using parentheses because there's no equal sign. So going this way, right? Because the x is going that way, so the parentheses has to be facing that way. For this one is less than or equal. So for this one, we're using brackets, and they're facing this way because it's less than that number. Okay, what are we shading? Everything in between these two things. This helps you for the interval. The interval would be just copy what you draw on the graph. What number is this? 2. What number is that? 4, and that's the interval. It's everything in between these two numbers. The only difference is 2 is not included. It's not part of the solution, but it helps us, right, see where it starts after the 2. And 4, it is part of the solution because it's equal to 4. So that's why we have brackets. Okay, for number 10, it's more the same except that you now need to solve. So we're going to have to solve for x. So this is where you guys pay attention. So imagine this is like 2 equations at once. We're solving 2 equations at once. So we're going to first get rid of that number. We want to solve for x. So that's a negative, so we're going to add 3. This is the only difference. You can add 3 to both sides. So that becomes 0. So see, we add it to both sides. So just copy these inequalities, carry down the 2x, put it in the middle. Okay, and then simplify this side. Negative 1 plus 3 is positive 2. 5 and 3 is 8. Okay. Now we're going to divide by 2. We need to get rid of that 2. We need to leave x by itself like it was in this original question. X by itself. So divide by 2 again, both sides of this compound inequality. So that becomes a 1. So you bring down the x, copy this inequality, the symbols. We divide it by positive, so that's not going to change. So 2 over 2 is just 1. 8 over 2 is just 4. So now we have it in this form like we had it over here. Now, to graph it, put a dot on 1. Look for 1, positive. It's right here. And then look for 4. It's right here. Now, okay, let's look at this side. So it has to be greater than or equal than 1. So this is 1 and x has to be greater. So it's going to go that way, greater than 1. But it's also less than 4. So that's 4. Less is this way. So it's going this way. And they're kind of intersect right here. Overlap. Now, what are we using parentheses or brackets for this one? We're using brackets because of the equal sign, and for this side we're using parentheses because it doesn't have an equal sign. And this is the graph, right? And now for the interval, it's right here, brackets, the 1, comma, parentheses, and the 4. And that's the answer. So I'm gonna leave this for actually, let me see. Yeah, I'm gonna leave it for you guys. It's I want to challenge you, see if you guys know how to solve this one. It's just like an equation. Now for translations, solving inequality applications, so we're gonna have to translate. We're gonna have to understand. I'm putting these two together, and then we're gonna have to solve and interpret. Because sometimes answers, when you solve the answer, it's sometimes the answer that you get when you solve it is not the actual answer. You need to still interpret the answer and see what's the answer. And it's better if I explain it. So for example, let's translate. Let's read it. 12 subtracted from 3 times a number. So remember, number, we can say it's an x. So 3 times an x. and 12 is subtracted. So be careful with this. And this doesn't mean 12 minus this. And then let me translate. So we have the 3x, which is, so in words it would be 12, either you see 12, and they're saying subtracted from that. Remember those boxes that I did 3 times a number, so in words is 3 times a number, so at the other box it's less than, that's is less than, so it has to be less than. That's where you use the inequalities. Less than what? 21. 21. So these are the boxes. So if we translate it, that's why I said be careful with subtracted from. This is being subtracted from this. So this actually goes first. 3 times a number, 3 times a number, x, so 3 times x. Subtracted, so 12 is subtracted from this, so minus 12. And then it has to be less, is less than. Not equal, it's just less than 21. And then that's when we solve it. I'm going to put it over here. 3x minus 12 less than 21. So now we just solve for this one. So plus 12. So that becomes a 0. Bring down the x. 21 plus 12 is 33. And then divide by 3. So x is less than 11. Alright. So let's interpret. So find all the numbers that make this statement true. And that one, it's already here, like it's stated here. Sometimes it doesn't, but in this case it does. So anything below 11 would make this true. So the answers would be, just to give you an idea, it would be 10, 9, 8, 7, and so on until you get to 1. So 11 won't work because it has to be less than 11. But anything below 11, which is 10, 9, 8, 7, and so on, that would make this statement true. And if you don't believe me, let me check. If you put the 11 here just to make sure, if you put the 11, what's 3 times 11? 33 minus 12 gives you 21. So 21 is not less than 21, they're equal. So you see, that's why 11 is not part of the solution. 10 it is, and I'm just going to check 10. 10 minus 12 is less than 21. So 3 times 10 is 30 minus 12, that would be 18. It's 18 less than 21? Yes, so it checks. So anything below 11 is the answer. That's where the interpreter means. Now the last one. So they're going to give you a word problem. We're going to have to translate and solve. Okay, so let's read it. Mary Chase and Jonathan Edwards are having their wedding reception at the gallery reception hall. So they're having a wedding. They may spend at most, so that's the key word, at most, that amount. What does that mean? At most would mean they can spend that amount or less. So it can be equal to this or it can be less. So I know we're gonna use something like this. The inequality unequal. So keep reading. For the reception, if the reception hall charges a $100 cleanup fee, so that's just a constant they charge plus 36 per person. Person would be the x. 36 per 36x. So every person is going to be $36. Find the greatest number of people that they can invite and still stay within their budget. So that's the budget, 2000. So let's translate it. So first is the cleanup. They have a cleanup fee. Which is, I'm going to put it here, $100. And what else? You're adding to the cleanup fee the cost per person. So the cost per person. So plus, what's the cost per person? 36 per person. So 36, and then we're gonna name a person X because we still don't know how many we can invite without going over that. And then it says here at most means at most. I'm gonna put at most, and the book has also must be less than or equal. So that's they mean the same thing. At most or this. At most what? $2,000. So this means at most means less than or equal. So whatever you're spending on this side has to be less than or equal to $2,000. So from here we're gonna solve it. So let me write it over here. So 100 plus 36x less than 2,000. So now let's solve it. So we're gonna subtract 100 first. That becomes a 0. So 36x less than or equal to 1,900. And then you divide by 36. That becomes a 1. So x has to be less than or equal to this thing, which gives you 52 and 7/9. Okay. So remember, this represents persons. But if you think about it, what's the actual answer? 7/9, this part. There's no such thing of a 7/9 of a person. So how many can we actually invite? 52 or less. Because we can't invite 53 because we know it has to be less than 53 because it's 52 point something here. But again, we can't have point of a person, point something of a person, so we have to invite 52. So that's how many people we can invite. We can invite 52 or less persons. Right there. And that's it, guys. Thank you.